Okay, so for the current search, I've got this folder and it's outputting, um, yeah, so these finished files uh, show graphs that finished searching and they also have 50,000 descendants or more. Um, so, yeah, the one I posted in the group was this guy, and he's got 1.6 million descendants. So if we can figure out a rule to prevent this guy, it would save a bit of searching. Um, so let's see, let's load him up in the simulator. And yeah, so here's one view of the graph, and then here's the usual view. Um, okay, so you can sort of see that this guy tends to collapse. Yeah, these center ones go to that 4 vertex, and these guys sink into their vertices. And we can look at this other view of the graph, and let's see, we'll change these middle colors to null because they're only used once, and then yeah, it seemed like if you get rid of the green colors altogether, turn those to null, then I'll retile. Okay, still sort of get the same behavior. And yeah, so just sort of probing around is helpful, and also you can see these faint green lines and they're red lines depending if that if that joint is too short or too long. Um, yeah, it'll show the faint line, so that can sort of be a hint of what's going on. Um, so it looks like here I think what's going on is, yeah, for example, this 0 vertex, it's connected to 9 and 2, and yeah, that's sort of like a straight line thing, so he can't come out too far here because yeah, the length from 9 to 0 and 0 to 2, that'll sort of pull him in. And then 0 is attached to 18 and 17, so if you pull these guys out too far, then yeah, 0 will get sucked in, and then it'll bring 18 and 17 with it. And then yeah, I think it's sort of same idea for these guys too. So 13, yeah, 14 looks like he's got some room to wiggle around. If you move 13 up, then that brings 5 up, but 5 wants to get pulled down. And that when 5 comes down, then that brings 13 in again. So yeah, so the simulator is sort of useful to get some insights like that to see what the important connections are. Yeah, and as long as I'm making a video, maybe I'll show off uh, what other files are in here. So yeah, so these finished files are sort of nice because it'll show. Yeah, so if we find a graph that's invalid uh, for one of these guys, then figuring out a rule to prevent that graph from happening will prevent a lot of descendants. So that's kind of handy. But yeah, it turns out I'll bring in a bunch of these other graphs, and most of them seem just fine. But yeah, once you get to a lot more vertices, then you tend to have a lot of issues. Yeah, so finished 16 means there's 16 polygons in here, and then yeah, so they're sorted a bit by size. So yeah, if I bring one in with, yeah, this guy's got, let's see, 90,000 descendants, and he's pretty big, so I sort of expect him to have a few failures. And that looks like, yeah, this is probably a descendant of that guy we just looked at. Yeah, maybe all of these are, I don't know. But yeah, you can see you get like a big mess. Yeah, and there's lots of problems here, but yeah, you can sort of, sometimes I'll just delete a bunch of vertices and retile. Make it a simpler graph, but it's still got issues. And then once it's sort of, once it's almost good, then I'll change these vertex colors to null. And I can sort of like probe around and see like, yeah, so it looks, I made some changes and it looks like now it's fine. So maybe I sort of want to start over or try to revert some of these changes and see what's exactly important. Yeah, and down here I've got these planar files. These are sort of like the record. When it finds a new record size, then it'll post these here. So these are just huge messes. Yeah, so this has, yeah, at least maybe 80 vertices, at least. Yeah, these are just huge messes. And then, yeah, yep, so that's the simulator.